So when it comes to air couplers, should you buy a metal air coupler or a plastic air coupler? It's obviously really, really hard to trust plastic, you know. Metal, or brass in this case, is what we build pretty much everything out of. We all trust metal. I don't think I've ever seen a plastic ratchet before. So I don't know if this is going to work, but what we're going to do today is we're going to tear on the inside of this plastic coupler and see if it's worth anything, you know. These guys, the reason why I bought the plastic one is because I'm having issues with these air couplers here. They leak every once in a while just from the moisture being inside of there. And this is a high quality Milton air coupler. I don't know if you can see that stamping on there. Now, these are good couplers, or at least they should be, but I have issues with them leaking. So I'm going to tear this guy apart, tear that guy apart, see which one's better. So I'm not going to show the tear down of the metal coupler. I'm not really too interested in that. What I am really interested in is this guy. So like I said, we're going to tear this guy down. I want to test the durability of the end of this thing. So, you know, the threads on the back of this guy go probably halfway through this this little section here. I'm worried if that's going to snap off. So we're going to do, you know, we're going to put it up into a metal fitting, and then we're going to hit it sideways and see if we can snap the end of this guy off. We'll do that a little later. But definitely want to tear this guy down. Another thing which I want to note, hopefully you can see this, there is a plastic diaphragm in there, or whatever it is, it's transparent. So that's going to be really interesting to see what's inside of this guy. On this guy, it's a piece of rubber that seats up against, a piece of rubber and metal that seats up against, that's what's leaking, that seats up again and seals the air. I bet you it's that plastic diaphragm that's sealing it on this guy. Anyways, start tearing it down, see what's on her. Okay, so here's the Milton torn apart. Here's that retaining snap ring you saw earlier. Here's the collar that snap ring lets loose. Here's a little spring. Doesn't look very good, or it doesn't look that bad. It's got a little bit of rust on it. This guy doesn't rust that much. It's external to the air system. What does rust is this assembly here. So this spring is normally inside of there. That would thread into that guy, and we took that apart. This is the culprit. This is what always makes the Milton air chucks leak, and you can see how much rust is developed on the back of that guy. These are two parts. They don't want to come apart right now. They have welded themselves together. The reason why this starts rusting is air systems just inherently get a lot of air, a lot of water flowing through them. And then this steel piece needs to seat against that rubber component in there. But it gets all, I don't know how that's showing up on camera, but it gets all flaky from rust. You can scrub them off, you can clean them with some WD-40 and a wire brush, put them back together, and they'll generally seal. But yeah, this is what I'm tired of. This is why I bought a plastic chuck. Oh, and you can see these guys are like all black and stuff like that. That's nothing, it's not dirt or grime or nothing like that. It's just dry lube I put in here every once in a while, just to keep everything moving freely. You can see the ball bearings here. They look totally fine every time. I don't know what they're made out of, but it's some good stuff. They never get rusty. All right, time to figure out how to get this guy apart. Just looking at it, there's no immediate way that I can see to disassemble it. Maybe there's a threaded piece inside of here, so we can put it in the vise here, grab it here, and hopefully unthread it. The other thing, which I hope it's not, is this piece right here might have some fingers that are like one way, because this, I don't know, the diameter of this guy can slide over like this. So that might be how they're assembled. They slide over, and it's got some one-way paws in here that don't let it slide backwards anymore. Then I can get it at least. So I'm going to put it in the vise here, see if we can unscrew it. That's a tiny little flange to actually grab it by. And it's pretty much deforming already. That's nice. So I don't know if this is actually going to bite or if it's just going to spin. Yeah, no. Ain't no way to hold that in the vise, and it's just marring the cheap plastic stuff. Okay, I think what I'm going to do is I'm just going to cut this gray part off. We'll see what's inside of there that way. I really didn't want to do destructive testing, but I just got to see inside of them. I want to know if they're good or not. Before I split this guy apart, I do want to note here, you see that shiny metal, that piece there? That is metal on the inside, so that's always subject to rusting. That might just be a seat for the, oh yeah, these are M-style fittings as well, so both the metal one and this plastic one are for M-styles. That metal piece just might be a seat for the fitting that goes inside of here, just so it doesn't wear out the plastic, but who knows. I was just curious, that's probably going to rust. So tearing her apart, you can see there's a retaining, that spring in there. Keeps the chuck from going down. We got some ball bearings. Hopefully you can see that. Hiya. Probably should have cut this on two sides. And hopefully nothing goes springing across the shop. Yeah, so pretty sure I was right here. I don't know if you can see that, but this is ramped on one side. On this side, it's flat. So this would be like a one-way assembly thing. So these are non-serviceable, unfortunately. You would just push this on over like this. They probably have something to press on this flange. You wouldn't be doing it by hand, and it would snap. This thing would just deform, kind of grow in diameter or radius or whatever, and it would snap over that. So the only way to get it off was to cut it. Okay, maybe not. So I tried to press it on from the backside, and that's a lot of expansion. Our cut was nowhere near the size of that. So maybe it doesn't slip on like that. I don't know. Keep investigating. Ball bearings going everywhere. Oh, God. I don't know why I'm saving these things. I'm pretty sure this chuck is not going back together. So there we go. Got the spring removed, ball bearings removed, and I don't know if you can see inside of here. There's definitely a little groove in there. These guys might thread together. So maybe it's serviceable. I'll put it back in the vise, try to take it apart. Well, that didn't work. The vise just marred the crap out of it. The wrench kept slipping on these flats over here. I guess that means more angle grinder. I want to get inside this thing. Don't really see a way how. Maybe this is glued inside of here. No idea. So I'm gonna, we got the groove in one side, but I can't get it apart, so we're gonna flip it over, cut the other side. It is so weird talking with earplugs in. I had to take them out. There we go. So look at that in a second. But yeah, right there, it definitely looks to me like this groove right here. Like these are two separate parts, and perhaps they are glued together. The angle grinder might have melted away any identifiers of threads. Oh, no, it did not. Ah, dang it. It was threaded. So I don't know how the heck you would actually grab that good enough to get it to spin. It was marring the crap out of this in the vise when I tried to spin it. And yeah, there was no way getting that apart. Maybe it's glued after the fact, like they, put glue on it, assemble it, and then the glue dries after. No idea. Anyways, there's the internal component. She's hot. It's like somebody hit it with an angle grinder or something. But on the flip side, the components are serviceable. All right, so I've had this thing apart for a little while now, and to be honest with you, this is pretty nice. It's pretty cool. So this is the main body, and there's this second floating piece right here. This is pretty good. So here's the other side to that, which actually have an O-ring that makes sure it would seal, this white thing would seal against this body. And then this guy moves up and down inside of here, and you can see there's two O-rings on there. So explaining how it works, your air would come in here. It would normally just press against this. And this is where the light, I was shining the light through, and you could see it straight through the body earlier in the video. Anyways, air would come in here, and it would press against the backside here, and that would keep it shut. And then there's two O-rings that don't allow it to flow through these ports right here. But when you get a M-style fitting and you jam it in there, this thing slides all the way back. And then now the air can go here, and it can flow around. Those O-rings aren't sealing anymore. It can flow into this port and then out here into your fitting. All in all, yeah, seems pretty darn well done to me. There's no lube on the O-rings, but that's not really an issue, I don't think, because generally plastics are self-lubricating. Another thing I liked about it too, on like the Milton design right here, you can't see it in there because of shadows, but the Milton, there's pretty much a flat rubber piece that seats against this bottom part right here, and that is what seals your chuck, and that's pretty much it. And then I've seen other style fittings where there's an O-ring that sits around the outside of this piece right here. The ones that seat right there, I freaking hate. They leak all the time. This one is really, really cool. Probably can't see it in there, but there's like a little felt piece in here. It is not an O-ring, and then it's got a lip further down in there. So what it's doing is it's actually seating on this entire flat part right here, and it's grabbing the bottom of it. And, even out of the entire fitting, like there's a pretty tight connection there. I honestly really like that. And it still swivels pretty freely. Yeah, these things are nice, man. Pretty darn cool. And seeing how it works here, so this would be how it's closed, and then you would jam your fitting into here, your M-style fitting. It would go like that, and then you could probably see the holes here. Right here's a divot here. That would be where your ball bearings sit. It would sit in this groove of the M-style fitting here, and that would keep everything pressed together. It would keep this flow path open, and that's how you would get flow coming to your fitting here. And then you would hit that release collar, which was this guy we cut off earlier, and everything would just pop right out. To be honest with you, these are really nice. I don't really think there's going to be any wear paths because, right, when this guy goes in, that metal piece is your misalignment collar probably. So when it's coming in at a slight angle like this, it's going to run against that metal part and then go into the rubber seat. All of those things should be pretty hard wearing, I think. This is honestly really nice. I didn't expect this. This is a pretty cheap plastic fitting. Yeah, I like these things a lot. Unfortunately, the only thing I can't do now is I can't do the side load testing I wanted to do on this. So when this guy is all assembled together and it's in a fitting, I would be worried about this guy cracking off right here where the threads are. You know, those threads make stress risers, and it's a bad thing, obviously. The metal is just a far more resilient material in most cases, and I've never had one of these metal couplers break, even though the wall thickness is a lot thinner on the metal couplers. So I don't know, maybe they're compensating with that with this plastic design. All in all, looking at the internals, looks pretty darn good to me. Oh, and probably the biggest thing, the sealing surfaces cannot rust because they're all plastic. So this should be perfectly fine dealing with moisture. The only metal parts are this sliding spring right here. There's one of those on the Milton. So this is just the return spring for this collar here, or in the Milton's case, this collar here. I've never really had an issue with these springs right here rusting on the Milton one. So got every reason to trust the ones on these ones. Another thing I really like too, if you look around the plastic body, there's actually 6 ball bearings, whereas on the Milton, there's only 3 ball bearings. I don't know, the 3 works fine, but ideally 6 is going to give you better locating of the M-style chuck here. You know, there's only 3 points of contact around here versus 6 points of contact. So these are pretty cool, man. Pretty darn cool. You gotta say though, I do love the stampings on this Milton chuck. And the knurlings. Be sad to see that go. This definitely doesn't feel as nice as that knurling. So, got the metal coupler back together. Ain't no way that guy's going back together. But I do want to do some destructive testing with this guy. And here's really where my air system is for. So, I had these little air trucks right here. There was normally a metal one there, but this plastic one has been on the truck for 2 or 3 weeks. It's been fine. I've used it 2 or 3 times. But essentially, I have this 4-tire air system that hooks up to this truck. A lot of times it gets moisture on them, and then these will start leaking. Systems don't have pressure, so that's the whole point of me buying these plastic ones. Really want to do some side load testing on this crappy little plastic one. So the weird thing about tightening up these plastic couplers, you can never really tell when you're tight because, you know, they're plastic. You can always feel that, like, you know, stress and strain, you know, when you're doing it in metal, but you can't really tell when it's in plastic. Anyways, that's like totally seated in this fitting. We're going to put a little bit of side load on her, see if we can't break it off. So I guess I've already done a little bit of side load testing on these guys. I got a rubber boot that sits on these, and you kind of got to pull them off, and when you're pulling it off, sometimes you end up side loading it a little bit. But anyways. Oh, no way. That wasn't even that hard. Yep, it's busted. Get you in just a wee bit closer. Sure you could see that. That was not that hard. But that is definitely, whoop, got a little hello crack in there. Okay, so yeah, as I suspected, does not take side load very, very well. Okay, I mean, that just straight up pulled fibers out of there, cracked a big chunk out. Other than that, good. Side load, no. That was not even hard. Another thing that sucks, that's also probably pretty stuck in the fitting there. I don't know if I'm getting that out or not. Plastic air trucks, are they any good? I would say yes. Looking at the internals, there's no way anything inside of here is going to corrode. That side loading thing is definitely an issue. You're going to have to be gentle with these guys. But, you know, if you have a plastic truck, you don't have to deal with the rusting and the leaking that constantly occurs on those Milton trucks. For the life of me, I do not know why they don't make that little internal seat in there out of brass. It seems like every time it rusts, it starts leaking. It pretty much every single time. Anyways, I'm going to go buy 2 more plastic trucks, and we're going to put them on the truck. I'm going to leave them on there for a while, and then I'll buy another plastic truck and put it on my air compressor. It's behind all of this crap right here. Only time will tell if they're actually going to last, but I'm going to be happy with them not leaking.